everyone. My name is Stephen Trussell, and with me is Hunter Massey, Stephen Brock, and Dean Hayward. For the past year, we've been working with DRS Technologies to create a people counter. Last semester, when we presented our project at the Senior Design Day, we had our counting algorithm working. This semester, we've expanded upon that to make a full-rounded product that will also track the directional flow of people as they're moving through the area, as well as make it wirelessly connected to your computer where the system will be running. Currently, our system is made of 4 parts. We have a case that holds our Tamers 320 thermal infrared camera, which has a 40-degree lateral field of view. It also is connected to a leopard board, which is used to acquire the frames from the camera. And this board connects to will connect to a wireless router via a wireless access point, which is also inside the case. This case you just pretty much plug in, and it will connect to your. After you connect the wireless access point to your router, you will then connect. It will be connected. So all you have to do is just plug it into the wall or wherever you're plugging it in. Place the case, and it works. On our computer, which if this was purchased by your company, would be on a server. It is 2 separate algorithms that will be running in conjunction with each other. First, we have a counting algorithm, which uses local binary pattern, which is a library built within OpenCV, which is an open source computer vision library. This local binary pattern will observe the frame that's acquired and then determine if it's a person or not. Areas in the frame that are considered a person, which we are looking at their heads for our scenario, is then boxed. This information is then passed along to our tracking algorithm, which was customly made for our project. Here we look at frame by frame. We track the position of the box as compared to the frame position in the previous frame. So therefore, we can tell which direction it's flowing. And then when it reaches the edge of the frame, it is then counted, because we know that it's for sure that this person is moving from right to left. And then finally, we do have capabilities for logging and online uploading of the information. However, for our demo today, it is turned off because we do not deem it to be necessary right now. Overall results for our counting algorithm, we have an accuracy of about 87%, which is up from last year's counting algorithm. Also, the tracking, it tracks about the same percentage, about 87% accuracy. If y'all would like to stop by our booth in the open area where we do a poster presentation, we have it set up, and you can see it live in action of the people getting counted, identified, and then their direction of flow being tracked. I guess we will open the floor up for any questions.
What are the main factors that affect accuracy?
The main factors impact accuracy. In terms of the counting, our cascade, which does our local that does the identification, is based off of a library of about 2,700 images of considered positive images or negative images. Positive images are going to be images taken with the camera of, let's say, people walking by, and then we go in, take those images, we place a box around their head, and then it is fed into our system. We train it to identify these areas. In terms of the accuracy, like lower accuracy, this might be due to people walking right behind, not the ideal contrast between the head and the background. Some of these factors will deter from the accuracy.
One other question, do you know what percentage of accuracy is
like I said, right now, the county algorithm we have looked up is about 87%. We did, at the same time of our testing, we also checked the false positive rate, which is let's say an object comes through that's not a person, that we know for sure it's not a person, but it gets counted by the algorithm. Right now, it's about 12% false positive rate, which is lower from our last semester's work.
But just to put on there, that's not for the tracking on the direction of travel. That's just for in a specific frame at a specific time. That is pretty much
just trying to count people egressing or ingressing from an area, right? That's what you're.
That would be that was our goal. We ideally see this being implemented in, let's say, a mall scenario where you want to place a new advertisement. In this, you can track the direction of flow of people, and then now that you have a statistical base of how many people are walking through this area that's going to be walking by and seeing this advertising sign, the mall owner can then go to the company that's wanting to buy the advertising space and say, look, we know that X amount of people are walking this direction in an hour. Where this flow is going towards, let's say, a certain